Welcome to another Ziva Math video. In this video, you will learn how to solve and graph two-step inequalities. You'll find the steps to solving inequalities to be the same as the steps to solving two-step equations, except for one rule. If you multiply or divide both sides of the inequality by a negative, then you must reverse or flip the direction of the inequality sign. Let's get to our examples. For our first example, we have 3x plus 6 is greater than or equal to 12, and we're going to solve these like we solved two-step equations, which means our 3x is what we're going to need to isolate first. And you're going to need to keep the left-hand side and your right-hand side balanced for now. So we have 3x plus 6. If I want to isolate 3x, that means I'm going to need to subtract 6, my inverse operation. If I subtract 6 on the left, I'll need to subtract 6 on the right. So back on the left, I have 6 minus 6, which is 0, which leaves me with 3x on the left. And on the right, I have 12 minus 6, and 12 minus 6 is 6. And at this point, I haven't done anything to need to flip my inequality sign. So I have 3x is greater than or equal to 6. Now I have a one-step inequality, and I'm ready to isolate x. And I'm going to do that by dividing both sides by 3. And on the left-hand side, through my division step, these 3's are going to simplify out, which will leave me with x on the left. And then I have 6 divided by 3 on the right. 6 divided by 3 is 2. Now, that rule was if I divide or multiply by a negative, I'll need to switch that inequality sign. Well, here I divided by a positive. So my inequality sign is going to stay the way it is. So my answer will be x is greater than or equal to 2. And if you're going to need to graph this on a number line, we have x is greater than or equal to 2. Well, 2 is therefore part of my solution set. So I'm going to use the closed circle or a dot on 2 to show that 2 is part of my answer set. And I have x is greater than or equal to 2. So the values that are greater than 2 are part of my solution set, which means I'm going to add the line with the arrow on the end of it going towards the right to indicate that my solution set includes 2 and all of the numbers greater than 2. For our second example, we have negative 2n minus 5 less than negative 17. And we put some integers in this problem, but your steps are still the same. We're going to treat this like a two-step equation where you're going to want to isolate negative 2n first. And whatever you do to the left-hand side, you're going to want to do to the right-hand side of your inequality. So we have negative 2n minus 5, which means our inverse operation is going to be to add 5. If I add 5 to the left, I'll need to add 5 to the right. On the left-hand side, I have negative 5 plus 5, which is 0, which leaves me with negative 2n on the left. That's what is isolating our negative 2n. And then on the right-hand side, I have negative 17 plus 5. That's adding integers with opposite signs. So we're going to subtract 17 minus 5 is 12 and keep the sign of the number with the larger absolute value, which is the negative 17. So on the right, we'll have negative 12. I haven't done anything so far that would require me to flip my inequality sign. So I have negative 2n less than negative 12. And now I have a one-step inequality where I'm going to need to isolate my variable n. And I'm going to do that by dividing by negative 2. If I divide by negative 2 on the left, I'll need to divide by negative 2 on the right. On the left-hand side, those negative 2's will simplify out, leaving me with just n on the left. And on the right-hand side, I'll have negative 12 divided by negative 2, and negative divided by a negative is a positive, and 12 divided by 2 is 6. And here, we need to notice that we divided both the left and the right by a negative number, which means that we're going to need to reverse or flip that inequality sign. So instead of a less than sign, we need to change it to a greater than sign. So I'll have n is greater than 6. And if we need to graph this on a number line, I have n is greater than 6. Well, 6 is not part of my solution set because it's only numbers that are greater than 6. So this time we're going to use an open circle showing that 6 is not part of my solution set, but every number greater than 6 is. So I'm going to add that line going towards the right. So the open circle shows that 6 is not part of my answer set, but everything to the right with that line is. For our third example, you'll notice I put the variable on the right-hand side of our inequality sign, but that's not going to make any difference to our steps. So we have 8 is greater than c divided by 5 plus 10. And our steps are going to be to isolate c divided by 5 first, so that's what I'm boxing up. And again, if the line helps you to make sure that whatever you do on the right-hand side, you do on the left-hand side of your inequality, go ahead and add it now. So we have c divided by 5 plus 10, which means our inverse operation is going to be to subtract 10 to get c divided by 5 by itself. If I subtract 10 on the right, I need to subtract 10 on the left. Looking at the left now, I have 8 minus 10. And I can think about this as adding integers with different signs, which means I'm going to subtract 10 minus 8, which is 2, and I keep the sign of the number with the larger absolute value, which is the 10. So I'll have negative 2 on the left, and on the right-hand side, 10 minus 10 is 0, which leaves me with c over 5 on the right. And I haven't done anything yet to need to flip this inequality sign. So what I have is negative 2 greater than c divided by 5, a one-step equation where I need to isolate c. And I'm going to isolate c by multiplying by 5. Multiply by 5 on the right. I'll need to multiply by 5 on the left. The 5's on the right through my multiplication steps will simplify out. And that will leave me with just c on the right. On the left, I have 5 times negative 2. A positive times a negative is a negative, and 5 times 2 is 10. So looking at the step that I just took, I multiplied both sides by 5. I multiplied by a positive. So my inequality sign is going to remain the same. So I'll have negative 10 greater than c. When we go to graph this on our number line, we're graphing negative 10 is greater than c. c cannot equal negative 10. Negative 10 is not part of our answer set. And since negative 10 is not part of our answer set, that's why we're using the open circle at negative 10. Now with the variable on the right, you need to be careful with what this says. This says negative 10 is greater than c. Negative 10 is greater than all of the numbers that are part of my answer set. So numbers to the left of negative 10 are included in the answer set, which is why the line is going from negative 10 and going left. For our final example, we have negative h divided by 6 minus 4 is less than or equal to negative 2. And our first step is going to be to isolate the negative h divided by 6. So you may want to box that. And if adding the line through your inequality helps you make sure that whatever you do to the left, you do to the right, go ahead and place it. So our first step is to isolate negative h divided by 6. I have negative h divided by 6 minus 4. So our inverse operation is going to be to add 4. If I add 4 to the left, I'll need to add 4 to the right. On the left-hand side, I'll have negative 4 plus 4, which is 0, which will leave me with the negative h divided by 6. But I want to clean that up just a little bit visually, so I'm going to put the negative with the 6. I'm going to rewrite this as h divided by negative 6, which is the same thing as negative h divided by 6. Then on the right, I'm adding integers with different signs, which means I am subtracting. 4 minus 2 is 2, and I keep the sign of the number of the larger absolute value, which is the 4. I didn't do anything to need to switch the inequality sign, so it'll stay a less than sign. Now I have the one-step inequality, h divided by negative 6 is less than or equal to 2. Until I isolate h, I need to multiply because that's the inverse to division, and I'm going to multiply both sides by negative 6. On the right-hand side, when you write that in, you may want to place the parentheses around the negative 6 just to make sure visually you're grouping the negative sign with the 6. On the left, my negative sixes will simplify out, leaving me with just h. On the right, I have a positive times a negative, which is a negative, and I have 2 times 6, which is 12. So I'll have negative 12 on the right. I multiplied both sides by a negative, which means I need to flip that inequality. So now I have h is greater than or equal to negative 12. And I can graph this on the number line as well. I have h is greater than or equal to negative 12. Negative 12, therefore, is part of my answer set, which means you need to use the filled in or the closed circle, and we're going to place it at 12. H is greater than or equal to negative 12, so your solution set includes all the numbers to the right of 12, all the numbers greater than or equal to 12, which is why we put the line from 12 going to the right. Thank you for watching. Be sure to like this video and subscribe to Ziva Math for more videos.